Greetings and welcome to Analyze. This is my favorite section, usually everybody's, I'm sure. It's the part where you get to use some of your proficiencies in math and statistics. After you've defined your problem and you've actually come up with some solid, what I call valid measures that are directly related to that problem, you have to do some kind of analysis. And usually they fall into three different categories. One is what I call descriptive statistics, and it's usually the first half of any kind of statistics course. It's those things that are measured directly, right? It has nothing to do with generalizing results to an entire population. It has more to do with how is it really, distribution, single variables, or maybe over time, and how it behaved, run charts, different what I call summary statistics, standard deviation, the variance, the high, the low, the median, all of those measures that are actually somewhat factually in terms of the sample that you derived in your measures section. Over time, this is pretty easy to do if you are measuring something over time. This is also where you generate a lot of your tables and figures for your report and presentation. Typically, your average learner in this class will be familiar with Excel and how to run a few of these analyses. Most often, if you take a Six Sigma course somewhere like for Black Belt, you'll be using Minitab. But in this course, we'll be using Excel. We'll be using Excel, either the analysis pack, and that is a add-in to Excel. If you don't know how to get at that, contact the instructor to walk you through that process. It's already in your Excel package, and you just have to check it off. Usually that and Solver, and then there might be a couple of others there that you need to check off before they're made active. Otherwise, Megastat is another, and that one is an entirely new drop-down menu in Excel that does all kinds of statistical testing and measures. This is the area where you really have to get your data in shape, get it into a spreadsheet, and perform that analysis. So the descriptive area is more or less something that you can report out on if it's something that's substantial, right? I'm not going to use the word significant, but something that's substantial. There's a saying in Six Sigma called variance is your enemy, right? So if you can get something under control that's out of control, like for example, time that it takes to do certain things, and it's all over the map, and you look at the standard deviation, and it's like really high relative to the mean, and then after some type of implementation, which we'll talk about next, and you take that measure afterwards, you may be able to see a marked difference between the two. And then it's stabilized, it's predictable, you can budget for it, those kinds of things, especially when it comes to delivering to the customer. The customer is a very important aspect of the analysis as well. There's another saying in Six Sigma called the voice of the customer, that everything that you do through this process, you should be listening to your customer. How would the customer view this? How is the customer benefiting from this? If the customer is not benefiting from this, why are we doing this? And so this is what I call a very dynamic kind of phase. This is the center of Six Sigma. Remember, it's define, measure, analyze, improve, control. This is actually the center of the process, and rightfully so. So the descriptives are just that. You're able to describe what that data behaves like in all alone, standing on its own as a distribution. Very important. The second kind of analysis is a little more complicated in that it requires some inferential kinds of statistics, and it's before and after. Something has happened. It's called a paired sample t-test, as that's the most widely used one. It's a differential. It's used for clinical trials. It's used for organizations if they've done some kind of initiative at a satellite and they test it out to see if it's working, and if it has a significant improvement, of course, not the other way around, but a significant improvement in performance of that key performance indicator, then you could say that yes, it could generalize to the entire population, and that would be the organization. You could roll it out with confidence that it's going to behave the same way at a certain level. If it's 0.05 at 95% confidence, that you'd have 5% risk, that it would not work like this when it's generalized to the entire organization. And that really is really up to the manager, you, to figure out what are you comfortable with. Are you comfortable with 5% risk, 10% risk, 15% risk? Obviously, if your p-value is 0.5, it's a coin toss, so no doubt you'd stay away from that. But typically in business and social science, it's 0.05, 5% risk that it's not going to behave like this. In science, it's the probability of rejecting the null hypothesis when it's actually true, which in this case would be the probability that there's no difference when there actually is. So it's really your risk moving forward with this project and generalizing it to the entire population from this sample, this one satellite. So this takes a little bit of doing, the analysis phase. And so here you're a scientist. You're really engaging in a research project. You're engaged in this investigation to see whether or not this is really going to work, how you're going to fix this thing that you defined early on and then you broke out into your measures. The third one is modeling, right? It's relational. And that is the most popular, that you see some kind of relationship between variables. And again, it uses the p-value. It defines your risk, but that there's some kind of relationship going on between and among these variables. It could be a multivariate model. It could be a bivariate model. So, for example, in education, I did one that was full-time equivalent students as a function of unemployment, right, over time. And I found for every 1% increase, there were 444.9 full-time equivalent students walking in the door, 1% increase in unemployment. And vice versa, walking out the door, over 15 years of data. Very important. To be able to make the right decision when it comes to hiring faculty, when it comes to drilling down into the departments rather than just the school. So you get into one of these projects, you start to learn things as you go. And by the time you get to the analysis phase, you might have shifted a little bit to be able to, because of the data, the availability of data, or things you found along the way. And that's okay, but you have to let your instructor know that you're taking a turn to the right or a turn to the left as a result of what you found. And will it still have the impact you thought it would at that define stage back in the beginning? So this is the time to pull out your old statistics book. Remember, Six Sigma, the assumption for it is that you've had a statistics class. And so you know what I'm talking about. There will be an overview. If you go into, there's a PDF file that I'm making available, and also in the textbook, there's Appendix A, that is all the statistics every manager should know, and it clearly goes into that. If it's survey data, you can do differentials, you can do modeling, or again, descriptive, differentials, or relational. Those are the three. You can select what you want. You don't have to do You don't have to do the, the inferential. You can just do the descriptive, and that's fine. But there has to be some kind of difference there, and that would be in the distribution itself. And so when you get done with the analysis, you should always create some tables and figures of that. For example, if it's relational, there should be a scatter plot. If it's a differential, how big is that difference? And so you should be able to display that quantitative information in some type of figure, and then you describe what that figure is right below it. You call it figure 3 or whatever in the order it appears according to APA. And so this is the crux of Six Sigma. And so what you find in the analysis is what you're going to do in the implementation stage, which is next. But again, this is essential to the entire project. If you don't do analysis, you don't have a Six Sigma project on your hands. Just by virtue of its name, you can tell Six Sigma, standard deviations from the mean, right? 6 standard deviations from the mean. That really tells you you're going to be working with statistics. And so this is a critical part. If you have questions about this, certainly you should talk to your instructor right away. Don't go down the road too far and then maybe go in the wrong direction. Get some guidance as you move forward to see if in fact this analysis is good. There are some bad analyses out there. I had one learner, for example, had something that was just too obvious. It was a ratio, and it was just wound up showing that the ratio works as relational. And so the instructor who's versed in statistics would be able to see that right away, that this is not a new find. This is not original. This is not, and it's not going to render any results. So make sure that you're in touch with your instructor all the way through this process. You have your variables, right? You should have at least a couple of variables you're working with. You have your selection of descriptive statistics, and that would be reducing your variance or a big difference in means, something like that, the high and the low. You're tightening it up. Whatever would benefit the organization is what you're after. Or the differential, and that would be before and after the implementation. And you might have to estimate what that would be till you get to the implementation. That's okay. And then the last is the relational. Is there some kind of relationship going on between these variables? A lot of times you'll get businesses that use kind of macro data to predict micro behavior, like I did with unemployment and full-time equivalent students. And you could, whether it's age, demographics, Nike does this, of course. GM has a great model. How many cars will be sold as a function of price of gas, the number of population, the cost of competitors, incentives that are given, and then marketing dollars spent, those kinds of things. So if you got that data over 10 years, it's fantastic. You can start to make really good decisions when it comes to budgeting, where you're going to put your money and where you get the biggest return on investment. Quality control. Six Sigma is really big on quality control. So you could even look at the quality control area. So revenue is a function of quality control. And so for every so much dollars, maybe 10,000, 100,000, $1 million you spend on quality control, what's the return on that? That's your coefficient for the model. So again, if you don't understand that, make sure you go back into your statistics book or consult with your instructor on how to interpret a simple regression model. And I think we'll leave it there. There's plenty to do in this section, so obviously this is probably the busiest section of the Six Sigma project, is the analysis. Thank you.